Good day, students. We are now in the first week of our third quarter. For our module number 2, I will teach you about factorials. In today's lesson, you are expected to simplify expressions with factorials. Let us have the pretest. Remember that you may pause this video whenever you want to reread the question, the choices, and the answer. Directions. Identify what is being asked in each question. Write only the letter of the correct answer. Number 1, the question is, what is the product of a positive integer n and all positive integers less than it? A. Powers of n, B. Multiples of n, C. N factors, or D. N factorial. Number 2. Evaluate 1 factorial plus 2 factorial plus 4 factorial. A. 27, B. 120, C. 720, or letter D. 5040. The answer is number 1, D. N factorial, and number 2, A. 27. Number 3. Simplify 6 factorial divided by the quantity of 5 minus 2 closed quantity factorial. Is it A. 16, B. 12 over 25, C. 120, or D. 11 over 36? Number 4. Which of the following factorial notation is not equal to 10 times 9 times 8? Is it A. 6 factorial, B. 10 factorial divided by 7 factorial, C. 5 factorial times 4 factorial, D. 5 factorial over 2 factorial times 4 factorial over 2 factorial? The answer is letter C, number 3. Letter B, number 4. Number 5. Which of the following can be the factorial notation of 42? Is it A. 7 factorial, B. 8 factorial over 6 factorial, C. 7 factorial times 5 factorial, or D. 7 factorial over 5 factorial? The answer is letter D, 7 factorial over 5 factorial. Before we start with our lesson, let us have a recap. I have here a situation. Rose, Sheena, Bobby, and Chris are to be arranged in a row for picture taking. Make a question that satisfies each conditions below. Case number 1. When an element must be placed in a specific position. Case number 2. When 2 or more elements must be grouped together. And case number 3. When 2 or more elements must not be grouped together. Are you ready to learn a new lesson today? Let's begin! To start our lesson, let us answer the given situation. Rose, Sheena, Bobby, and Chris are to be arranged in a row for picture taking. In how many ways can we do it? How can we solve this problem? To solve this problem, we must assign each person in each position. As there are 4 persons in a picture taking, therefore there are 4 positions. To show this, we will use an arrow diagram. There are 4 choices for the first position, and we can place any one of them. If I start by placing Rose in the first position, there are 3 persons left for the next position, and that could be Sheena, Bobby, or Chris. If I chose Sheena for the second position, then the third could be Bobby or Chris. And if Bobby is in the third position, then the last is Chris. And the arrangement is Rose, Sheena, Bobby, Chris. If I chose Chris in the third position, then the last is Bobby. If that is the case, we have the arrangement Rose, Sheena, Chris, Bobby. Now, if Bobby is in the second position, therefore the third position could be filled with Sheena or Chris. If Sheena is in the third, then Chris is last. Then the arrangement is Rose, Bobby, Sheena, Chris. If Chris is in the third, then Sheena is last, with an arrangement Rose, Bobby, Chris, Sheena. Now, if Chris is in the second position, therefore the third position could be Sheena or Bobby. If Sheena is in the third, then Bobby is last. This will give us an arrangement Rose, Chris, Sheena, Bobby. And if Bobby is in the third, then Sheena is last. Then the arrangement would be Rose, Chris, Bobby, and Sheena. Now, if Sheena is in the first position, by doing the same process, we will have these arrangements. If Bobby is in the first position, we will have these arrangements. And if Chris is in the first position, then we will have the following arrangements. By looking at the solution, we found out that we have the following arrangements. So the answer to the problem is, there are 24 arrangements if there are 4 persons to be arranged in a row for picture taking. Aside from listing, is there other way to solve this problem? Of course, there is another way. That is to observe pattern of choices in each position. This way, we are determining the possible outcomes. Recall that there are 4 positions: first, second, third, fourth. In the first position, there are 4 choices: Rose, Sheena, Bobby, and Chris. After choosing one, then there were only 3 persons left to choose from for the second, then 2 for the third, and then 1 for the last position. Thus, 4 times 3 times 2 times 1 equals 24, which gives us the answer. There are 24 arrangements if there are 4 persons to be arranged in a row for picture taking. What have you noticed about the factors? Yes, the factors are consecutive. The expression 4 times 3 times 2 times 1 can also be written as 4 factorial, which is also equal to 24. And 4 factorial is known as factorial. What is factorial? Factorial is the product of all positive integers less than or equal to a given positive integer, and denoted by that integer and an exclamation point. Thus, n followed by an exclamation point is read as n factorial. Let me give you an example. 5 factorial equals 5 times 4 times 3 times 2 times 1, which is equal to 120. 4 factorial is equal to 4 times 3 times 2 times 1 equals 24. 3 factorial is 3 times 2 times 1, which is 6. 2 factorial is equal to 2 times 1 equals 2. 1 factorial equals 1. And 0 factorial is also equal to 1. And as you can see, the factors are arranged in decreasing order. But what if the factors are arranged in ascending order? Yes, the answer is still the same. Whether it is arranged in a decreasing or ascending order, the answer is still the same because multiplication is commutative. Let's have examples for you to understand more. We will rewrite the following factorials. There are A, E, and C. Rewriting A, we have 12 factorial with the factor 9 factorial. Our solution is 12 factorial equals 12 times 11 times 10 times 9 factorial. You see, one of the factor is 9 factorial. Letter B, 15 factorial with the factor 13 factorial. So our solution to that is 15 factorial equals 15 times 14 times 13 factorial. And for letter C, writing 10 factorial with the factor 5 factorial, we have the solution 10 factorial equals 10 times 9 times 8 times 7 times 6 times 5 factorial. For our next example, we will evaluate each factorial notation. Letter A, B, and C. For letter A, we have 6 factorial. For us to evaluate this, we'll have 6 factorial equals 6 times 5 times 4 times 3 times 2 times 1, which is equal to 720. For letter B, we have the quantity of 6 minus 2, closed quantity factorial. So first, we have to subtract. 6 minus 2 is 4, so we have 4 factorial. And 4 factorial is equal to 4 times 3 times 2 times 1, which is equal to 48. To evaluate 7 factorial divided by 4 factorial plus 3 factorial, we have to first get the equivalent of each factorial, or the value of each factorial. And 7 factorial is 5040, 4 factorial is 24, and 3 factorial is 6. Then we have to perform the indicated operation, and that is 5040 divided by the sum of 24 and 6. This will give us the answer 168. For example number 3, we have to solve for x, or the value of x. So we have letter A, B, and C. For letter A, we have x is equal to 8 factorial. For us to get the value of x, therefore we have to get the value of 8 factorial, which is 40,320. For letter B, we have x plus 3 factorial equals 6 factorial. By APE, or addition property of equality, we have x equals 6 factorial minus 3 factorial. Then we get the value of each factorial, which is 6 factorial is 720 and 3 factorial is 6. Then we subtract. 720 minus 6 is 714. So our answer is 714. For C, to solve for x, we have 3x equals 4 factorial divided by 2 factorial. We will evaluate first 4 factorial, which is 24, and 2 factorial, which is 2. Then we'll have 3x equals 24 divided by 2. And 24 divided by 2 is 12. So I have 3x equals 12. Now by MPE, or multiplication property of equality, our x now is equal to 4. So our answer is 4. Let's wrap up the things you learned from this lesson. Remember that factorial is a product of all positive integers less than or equal to a given positive integer, and denoted by that integer and an exclamation point. It can be written as n factorial equals n times n minus 1 times n minus 2 times up to 2 times 1. 0 factorial, or 0 followed by an exclamation point, is defined as equal to 1. In the book, Anna's Mysterious Multiplying Jar, the author tells a story of a mysterious jar and how within it are an island, 2 countries within the island, 3 mountains within each country, 4 kingdoms within each mountain, 5 towns within each kingdoms, 6 homes within each town, and etc. Anna uses a mysterious jar while you will start with your own mysterious bag. Think of an item that can be put inside the bag that will follow this concept. Collaborate with your family members and try to reach 5 factorial. Let's have our poses to check if you learned something today. Remember that you may pause this video if you want to read the question, the choices, and the answers. Directions. Identify what is being asked in each question. Write only the letter of the correct answer. Number 1. Which of the following is true in the definition of factorial? The answer is letter C. Number 2. Which of the following is equal to 5 factorial? The answer is letter C. Number 3. What is 8 factorial divided by the quantity of 6 minus 2 closed quantity factorial? The answer is letter D. Number 4. What is the value of 4 factorial plus the quantity of 18 minus 13 closed quantity factorial? The answer is letter A. Number 5. Which of the following is not equal to 9 times 8 times 7? The answer is letter A. To apply what you've learned today, you will answer activities. For activity number 1, you will evaluate each factorial notation. For activity number 2, you will simplify the following factorials. And for activity number 3, you will solve for x. Now, it is time for you to check if your answers are correct. Thank you for listening. See you on our next video and happy learning!